All right, this is the Algebra 1, new Unit 7, Lesson 7 video over exponential equations and looking at what we call regression, which is a way of taking data and finding an equation to describe the data. So first thing to talk about is the actual formula that we use when we talk about exponential functions or exponential equations in algebra. So I want to talk about this equation, which is what we call like the general form or the standard form of an exponential function. And you can see, like we know, exponential functions are functions where the x, the variable, is an exponent, right? So there are two other values listed here. There's the a and there's the b. So let's talk about what those are. So the a term is the initial value of whatever you're measuring. So when x is 0 at the beginning of whatever time or thing you're looking at, that's the initial value. B is the growth or decay factor. So that's either going to be, so if it's growth, it's going to be greater than 1. If it's a decay factor, it's going to be between 0. Oops. Write this a different way. For growth, remember b is going to be greater than 1. And for a decay factor, b is going to be between 0 and 1. We talked about that in a previous lesson, but I want to make sure it's clear when it's growth and when it's decay. So one thing we're going to do is we're just going to interpret exponential functions. So let's take a look at some of the examples that they have for us. Let me scroll down here, bottom here. All right. So we're going to spend some time looking at the equations, and we're going to actually be creating those equations ourselves by using what we call exponential regression. So I'm going to jump over to a tab here that I've given you a link to in the video description. So what you're going to get is you're going to get a table at the top, and then down in here you're going to have this equation. You can notice it's the equation we just talked about. It's written a little differently because we're yet letting the calculator do some things behind the scenes that help us. So this is y equals a b to the x. And so what it's going to do, it's going to take the information in the table, it's going to graph it, and then it's going to find a line, an exponential line, that is close to those values. So let's look at one of their examples. So if you look right here, it says write an exponential equation represented in the table given. So you have x is 0, 1, 2, 3, and 4. So let's go ahead and type that into my x, 0, 1, 2, 3, and 4. So you'll want to do that. And then we're going to go to our y, and we're going to enter this other data, 820, 984, 1,180. Oops, I got to make sure I go to the next point. What is that? 0.8. 1,417. See that every time I'm changing one of these, the graph itself is changing as well. 1,700.4. So we've got a graph here. If you zoom way out, you can see the different values. And down here, they're going to give us what they call the parameters. So these values here are the a and the b value of that equation. So let's write down what this would be if I went ahead and put that into an equation. So it would be y equals a, which is, we're going to go ahead and put 820, we're going to round, times 1.2 to the x. So you see I've taken a and put it in the a spot, I've taken the b and put it in the b spot, and then gone ahead and gotten the entire equation. So this is what you have to do when it says write an equation for this data. So let's go look. And right here, that's the exact equation we just got out of that group of functions, or that group of data. So that's really all you have to do on this type of question. So you're going to go to the exponential regression graph. You're going to type, the information. If I can get my eraser on here, there we go. You're going to type the information in the table above, let it graph, and then look at the parameters A and B to find the values that go into the function. And remember, they go into the function in this format, A times B to the X power. So that's what you're going to do in going down here. Number 1, you have your X, and then you have this. This is going to be your Y. And you'll enter that data and get the A and B value, find the function that matches. All right. Then they're going to do it in sort of a word problem sense. So it says here, a radioactive substance loses its mass at a rate of 12% every second. At the beginning of an experiment, the substance has a mass of 6 centigrams. Which of the following equation best models the exponential function of the situation? Now, in this one, we want to use the information from the problem to determine in advance, without having any values, what the actual equation will look like. I mean, there's some things that we know. We know that the initial value is the A term. Let's start there. Well, I see that the initial value is at the beginning, it has a measure of 6 centigrams. So that means that there needs to be a 6 at the beginning. So that means this is going to go and this is going to go, because it doesn't have a 6. These have the 6 at the beginning. That's what we're looking for. And so then it just becomes a question of which is the correct growth or decay function. And it's pretty straightforward. We talked about this previously, but remember, your decay function is not this number. It's not 12%. It's actually 1 minus 12%, which is 88, which written as a decimal is 0.88, which is why we're going to choose answer choice D, or the fourth answer choice, as the correct answer. So that's the kind of thought process you have to go through. Number 3, same question. After 5 seconds, how much mass is left? So I'm not going to do everything for you here, but you're going to take 5 seconds and you're going to make that equal T equals 5. And then you're going to take the equation from the previous problem, which was Ft equals 6 times 0.88 raised to the T, and you're going to put 5 in for T. So let's jump over to the calculator so you can see how we type that in, so you know where to find those buttons. So the main button you're going to need is right here. It is the button for making an exponent of any value. So for instance, I'm not going to do the exact problem here, but let's say I had 4 times 5, or let's go back, 0.52 raised to the 4th power. So see, I'm doing the number, and then I'm hitting the A to the B button, and then that's giving me the actual exponent there. So that's how you do exponents in the calculator. So all you have to do on this one is plug 5 in to the formula for T right there. Okay, number 4, use the situation to choose the correct answer. So here we have the starting point, which is this first number, January 1st. There was 7,200 people. So what is going to be the equation? So we already know that if we look at the thing, we can tell that it starts at 7,200, which means that this is not going to be the right answer. And then all you have to do, and this is just common sense and no math needed here, is the population of this town growing or shrinking? If it is growing, pick the equation that shows a growth factor. In other words, a number for B that is greater than 1. If it's shrinking, choose one that's less than 1. I think you can figure this out without any more help from there. So I'll leave that one to you. More of the same. If the trend continues, what would the town be on January 1st, 2011? Now this one's a little bit weird, but notice that the 0 was 2005. they don't do a good job of explaining this. 2006 would be T1, 2007 is T2, 2008 is 3, 2009 would be 4, 2010 would be 5, 2011 would be 6, and so you're going to use T equals 6 in the equation that you found in the previous problem. So again, you are going to use T6 for T, and you're going to plug it into the answer you got from question number 4. So you have to get the right answer here in order to plug in 6 into the right formula. All right. Number 6, you have a table. You need to use regression to find the correct equation. Type in your x values and your y values. You're going to make this be x. You're going to make this be y. Plug those values in, and then use the parameters to find the correct function of the answer choices. Pretty straightforward. Once you do that, they ask you to find the correct graph. You already are going to have the graph on the screen after you do that. So use the graph that you see and match it with the correct graph on here. You'll be able to tell pretty easily which one of them is the correct graph. You can always look at individual points to find it. So I'll let you do that one. It's pretty easy. Then it asks, what's the mixture after 30 hours? So that's when T equals 30. So again, take the equation from question number 6. So from question 6, take the equation from question number 6 and plug in 30 for T to find that value. Again, you're just plugging in and solving for the actual value. Pretty straightforward. More of the same. This one, I think you can probably just guess the answer. It says that the temperature of the mixture is 400. How much time has passed since the cooling process began? You can see here 400 is going to be somewhere between those two values. So you just decide which answer choice you think is the best answer choice based on that information. All right, I'm not going to spend any more time on that one. Number 10, you need to create an equation, and then you need to do 2024. Just as a reminder, you need to go ahead and put 1, 2, 3, 4, 5, 6, 7. Instead of 2000, just use the first number, the last digit, 1, 2, 3, 4, 5, 6, 7, 8, 9. So then 2024 would be 14. Okay, so first things first, use exponential regression to find the equation for the table of values that you have here. So find equation, plug, step 1, 2, plug in T, and find the value for that. All right. And then there are review questions starting at number 11. You should be able to do those based on the material that we've already covered in class. So if you need help with those, just reach out to me. I think you should be fine on those. And that is it for lesson 7.